As you can see, the multimeter about 400 voltage. So if you get 400, 500, 700, all these values are good. So this is a good MOSFET. So let's check this MOSFET also. Nothing in the multimeter. So let's swap the probes. We get a reading. The same reading in the multimeter means also this is a good MOSFET. This is a 3-terminal MOSFET, the big one. Here we have 8-terminal MOSFETs, and also this is a 3-terminal MOSFET, SMD MOSFETs, source, drain, and gate. Okay. The black probe here in the negative terminal or the cathode, and the red probe in the positive terminal. We get already good diode. So here we have 10 telem capacitors, as you can see, 10 telem capacitors. The black probe in the negative terminal and the red probe in the positive terminal. Good. No short. This is a good 10 telem capacitor. This one also, let's check. Good one. Okay. Guys, we have short here. We have short circuit in this motherboard. So this one, this is inductor, not ceramic capacitor. As you can see, we have here PL. Okay. This one also is inductor. We have PL3. So let's check. Do you see? A very low resistance in the multimeter. So this inductor is good. Let's check this one also. As you can see. Okay. So the red probe in the source and the black probe in the drain. As you can see. We get a reading in the multimeter, means this is a good MOSFET. And this is of course in channel MOSFET. So between source and drain. So we get about 100. Let's swap the probes. Nothing in the multimeter. So the MOSFET is good. Please guys, don't forget to subscribe, share and like the video, because your likes and engagement really motivate me to create more useful video for you. So please like the video. Thank you very much. Hi, in this video I'm going to teach you step by step how to test using the multimeter laptop motherboard components, including MOSFETs, diodes, inductor, capacitors, ICs, resistors, Zener diodes, fuses, transistors, voltage regulators, chipsets, network resistors, LEDs or light emitting diodes, ceramic capacitors, tantalum capacitors, current sense resistors, and much more. So let's get started. So let's begin first by MOSFETs. Let's test these MOSFETs as you can see here. So basically there is many type of MOSFETs. 8-pin MOSFETs like this one, 3-pin MOSFETs like this MOSFETs. This is basically a power MOSFET, and also this kind of MOSFET. As you can see, this is a 3-terminal MOSFET. Okay, this is an SMD MOSFET. Okay, so I'm going to teach you how to test all this kind of MOSFETs. Okay, so first, to test MOSFET you should use the multimeter and choose the diode option. As you can see, the diode option, and then press the power button. So if you focus here, for example, for this first MOSFET here, we have here a mark, a white mark, means this is the pin number 1. Okay, pin number 2, pin number 3. So these 3 pins are source, the 4th pin are gate, and these 4 other pins are drain. I will show you the MOSFET in the schematic in order to understand it clearly. So here we have the MOSFET, as you can see. So do you see here the pin number 1, 2 and 3. These 3 pins are connected together. Here we have source, and the 4th pin, this is the gate. Here we have G means gate. Okay, so this is the gate, and 5, 6, 7, 8, this is the drain. 4 pins connected together. Okay, and do you see the diode? So the diode is between source and drain. That's why we will use the multimeter and check between drain and source. We should get a reading exactly like we test the diode. So here, as you can see, the multimeter is in the diode option. So let's now check between source and drain, okay? So as I told you before, these 3 pins are for source. If we check these 3 pins, we will get a canteen. As you can see, the multimeter, we get a buzzer and a low resistance. This also, do you see? Means these 3 pins are connected together. But if I check between source and gate, as you can see, nothing in the multimeter. Okay, and of course these 4 pins also are connected together. This is drain. So let's check. So between this pin and this one, we get a buzzer and a low resistance in the multimeter. Let's check with the 3rd pin, the same buzzer, 4 pin. As you can see, buzzer means these 4 pins are connected together as we see in the schematic. Okay, so let's test this MOSFET right now. Okay, so but first we should discharge the MOSFET. Okay, here we have the gate. So let's connect between the gate and the source, and even we can connect between the drain and the gate like this in order to discharge the MOSFET. So let's see right now. So the black probe here in the source and the red probe in the drain. Let's see. Here, as you can see, we get a low resistance. Okay, so let's swap the probes. We get the same resistance. So basically this MOSFET, this is not a short MOSFET, no, but this circuit here is for the CPU. So let's see the back of the motherboard. As you can see here, okay, as you can see, we have here the CPU. As you can see, we have 4 MOSFETs here and 4 in the back. So the low resistance here is for the CPU. If we remove the CPU, we will get the right resistance. Okay, so let's check again this MOSFET also. So here we have the source and here we have drain. Do you see? Low resistance. So let's remove the CPU and see again. So I will remove the CPU. Okay, so let's remove the CPU. Now the CPU is removed. Okay, so let's check any MOSFET here, for example this one. Do you see? No reading in the multimeter. So if I swap the probes, do you see? We get a 400 voltage. This is right, so the MOSFET is good. But if I put back the CPU, as you can see, so let's close the CPU here, we're gonna get also a low resistance in the multimeter. So please pay attention for the MOSFETs around the CPU. Always you should pay attention for the MOSFETs around the CPU. If you want to check MOSFETs around the CPU, you should remove the CPU and then check it, because when the CPU is connected, you will get a wrong values. Okay, so let's check these 2 MOSFETs, for example. So these MOSFETs are in the charge circuit next to the power jack. As you can see, this is the power jack. So these 2 MOSFETs should give a right value, but the MOSFETs next to the CPU, you should always remove the CPU. So let's check these 2 MOSFETs. So of course we should always locate the source. So here we have the first pin. We have this white mark, means this is the first pin, the pin number 1, pin number 2, and pin number 3. So this is the source and this is the drain. So let's check this MOSFETs using the multimeter. So of course the multimeter is in the diode option. So I'm gonna put 1 probe in the drain and 2 other probe here in the source. So nothing in the multimeter. So if I swap the probes, we should get a reading. So let's see. As you can see in the multimeter, about 400 voltage. So if you get 400, 500, 700, all these values are good. So this is a good MOSFET. So let's check this one also. So between drain and source, as you can see, nothing in the multimeter. So here, as you can see, we have this white mark here, means this is the source. Here we have the source, and here we have the drain. So let's check this MOSFET also, nothing in the multimeter. So let's swap the probes. We get a reading, the same reading in the multimeter, means also this is a good MOSFET. So here, as you can see, we have another type of MOSFET. This is basically a 3-terminal MOSFET, where we have this point, as you can see here, this white dot means this is the source, okay? This is the drain, and this is the gate. So source, drain, gate. So this pin here is connected to this part here. So if we check using the multimeter between here, the drain, and this part here, as you can see, a low resistance, okay? Means this is drain, and this is also drain. So source, drain, gate. So let's check between the source and drain. We should. So let's test this MOSFET. So between source and drain, so we get about 100. Let's swap the probes. Nothing in the multimeter. Okay, so let's check again. About 100. So the MOSFET is good. Basically, the reading is a little bit decreased, but the MOSFET is good. Once we don't have here the continuity like this, means the MOSFET is not shorted. Okay, we have here other MOSFETs. For example, let's check this one. So between drain and source, nothing in the multimeter. Let's swap the probes. We should get a reading, as you can see in the multimeter, 480 drop voltage. So here, as you can see, we have other 2 MOSFETs, as you can see over here. So this is the first one, and this is the second one. Okay, so this is other 2 MOSFETs. So here we have MOSFET. This is a 3-terminal MOSFET, the big one. Here we have 8-terminal MOSFETs, and also this is a 3-terminal MOSFET, SMD MOSFETs. So this white dot here means this is the source. Source, drain, and gate. Okay, and for this one we have source, drain, and gate. So if we test between the source and the drain, we should get a reading. Okay, depending on the type of the MOSFET. If the MOSFET is N-channel, means we should get a reading when we put the red probe in the source and the black probe in the drain. But if the MOSFET is P-channel, we will get the reading when we put the red probe in the drain and the black probe in the source. Okay, so let's check this 2 MOSFETs using the multimeter, and in the same time we're gonna identify whether the MOSFET is N-channel or P-channel. Of course, always we're gonna use the diode option, as you can see. So let's check. So here for the first one, this is the source. This white dot means the source. So I will put the black probe here and the red probe here. So let's check. Nothing in the multimeter. So let's swap the probes. So this time the red probe here, okay, in the source. So the red probe in the source and the black probe in the drain, as you can see. We get a reading in the multimeter, means this is a good MOSFET, and this is of course N-channel MOSFET. Why? Because we put the red probe in the source here, okay, and the black probe in the drain, and we get a reading, means this is N-channel MOSFET. So let's test this one also. So the red probe in the source, as you can see, and the black probe in the drain. Let's see, we get also a reading. This is also N-channel MOSFET. If I swap the probes, as you can see, I should get nothing in the multimeter. As you can see, nothing in the multimeter. Okay, so let's test again this one and identify whether this one is N-channel or P-channel MOSFET. So we have the dot here. White dot means this is the source. So let's put the red probe in the source and the black probe in the drain. We get a reading. Okay, so the red probe here is in the source and the black probe is in the drain, and we get a reading, means this is N-channel MOSFET. So let's test again this one and confirm whether this one is N-channel MOSFET or P-channel MOSFET. So here, as you can see, we have the white dot, means this is the source. So let's put the red probe in the source and the black probe in the drain. We get a reading, means also this is N-channel MOSFET. I hope that we find a P-channel MOSFET in order to know also about a P-channel MOSFET to understand clearly. So here, as you can see, we have some MOSFETs. Okay, this circuit basically is for the RAM. Okay, so let's check this MOSFET and look for whether we can find here a P-channel MOSFET or not. So let's locate first the source. We have this dot mark here, means this is the source and this is the drain. So let's put the red probe in the drain and the black probe in the source. So nothing in the multimeter. If I swap the probes, as you can see, I get a reading. So this is also N-channel MOSFET because the red probe is in the source. Okay, so here, as you can see, we have other MOSFETs. Okay, this is basically here the ICH circuit. Let's check if we can find P-channel or not. Here we have a white dot, means this is over here the source and this is the drain. So let's check. Okay, the black probe in the source and the red probe in the drain. Here we have short. Unfortunately, this MOSFET is shorted. So let's check this one also. No, this one, no. This one is good. But this one is shorted, as you can see. So this is a shorted MOSFET. This MOSFET is shorted. Let's check between the MOSFET and the ground, as you can see. Oh, so this side, the source is connected to the ground. And let's check the drain. We have a very low resistance, 002, means this MOSFET is shorted. So let's check another motherboards. So I hope that I can find a P-channel MOSFET. So for P-channel MOSFET is the MOSFET where we put the red probe in the drain and the black probe in the source and we get a reading. Okay, this is a P-channel MOSFET. So let's check these two MOSFETs. These two MOSFETs, I hope that we find a P-channel MOSFET. So first we should locate, as always, the source. So where is the source here? So here, as you can see, we have this hole here. Do you see this hole and this white mark over here? Means here, this is the source. These three terminals are source and this are drain. Okay. Okay, so this is we can even check using the multimeter. These four terminals should be connected together. As you can see, the first and the second, the third one, the fourth one. Okay, means this is drain and this is source. So let's check this MOSFET. We hope that this is P-channel MOSFET. Let's see. We get a reading. So this is a P-channel MOSFET. This is a P-channel MOSFET because we put the red probe in the drain and the black probe in the source. This one also should be the P-channel MOSFET. So here we have a hole over here. Do you see the hole here? Means this is source and this is drain. So let's check. Let's put the red probe in the drain, as you can see, and the black probe in the source. We get a reading, as you can see. Okay, so this is P-channel MOSFET. If I swap the probes, as you can see, Nothing in the multimeter. Okay, so this is, as you can see here, P-channel MOSFET. So this is all about the MOSFET. So let's check another component. Okay, so let's check for example inductor. Okay, so let's check inductors. So here we have inductors, as you can see. All these are inductors. So how we check the inductors? Easy, of course. We're gonna select the continuity option. So for the multimeter I have here, the continuity option and the diode option is in the same place. Okay. So now I check the continuity option. So let's check the multimeter. As you can see, the continuity option is seated correctly. Now to test the inductor, we should get a buzzer, a very low resistance, because the inductors basically are just a wire, a simple wire. So let's check this one for example. We should get a reading. Do you see? This is a good inductor. Let's check this one also. This is a good inductor. Okay. So let's check other types of inductor. For example, here. So here also we have other types of inductor. Okay, let's check. Do you see? Good inductor. Good inductor. This is another inductor. Okay. So I'm going to show you other type of inductor, SMD inductors, as you can see here. So this is inductor, not ceramic capacitor. As you can see, we have here PL. Okay. This one also is inductor. We have PL3. This is another inductor, as you can see, not ceramic capacitor. We have PL. So if I check this inductor, as you can see, I should get a reading here, a buzzer. So let's check. Do you see? A very low resistance in the multimeter. So this inductor is good. Let's check this one also. As you can see. Okay. But for this one and this one, this is ceramic capacitor. So let's check the ceramic capacitors. So to check the ceramic capacitors, we can even use the continuity option. The ceramic capacitors should never be shorted to the ground. So let's check the ceramic capacitor, for example. This is good. This one also. So this is good, as you can see. It should not be shorted to the ground. This one, for example. This is good. So the ceramic capacitor should never be shorted to the ground. Okay. Here we have other kinds of capacitors. This is basically tantalum capacitors. So those here and tantalum capacitors. So to test the tantalum capacitors, you should use the same working principle as any capacitor. So here we're gonna of course use the continuity option, okay, and check this capacitor. So this mark here, as you can see here and here and here, means this is the positive terminal. Okay, this is also the positive terminal. So let's check for example this one. So here we will put the black probe and this here the red probe. Oh, here we have also a short circuit. This capacitor could be the shorted one. So let's check this one for example here. Guys, we have short here. We have short circuit in this motherboard. Okay, this motherboard also is shorted. So let's test for example. So here, as you can see, we have other tantalum capacitors. So let's check this tantalum capacitors. So as you can see here, we have plus. So the black probe here, the negative terminal, and the red probe, as you can see here. Oh, we have a short here, but please wait. Let's remove the CPU and check again. Okay, because this resistance could be the resistance for the CPU, but I think we have the short here, so I remove the CPU. Okay, so let's check again this tantalum capacitor. So the black probe here in this terminal, okay, and the red probe here. Oh, we have short circuit. It's not the processor, no, we have short circuit. So this motherboard is shorted motherboard. So let's see another motherboard. So let's close first the processor. So by the way, if you want to close or open the processor, as you can see here, I have an open, close. To open, you should just turn this one to this direction. I have to close it to this direction, okay? So here we have tantalum capacitors, as you can see, tantalum capacitor. So let's check this tantalum capacitor. The black probe in the negative terminal and the red probe in the positive terminal. Good, no short. This is a good tantalum capacitor. This one also, let's check. Good one, okay. This one also, good one. So this is good tantalum capacitors. So now let's go to another components. Right now I'm going to teach you how to test diodes, including normal diodes and Zener diode. Of course, also we're gonna choose the diode option. You know, I like this option in the multimeter because 90% of my work in the motherboard I use the diode option and the continuity option. That's why I like this one. So please guys, don't forget to like the video. Please like the video because your likes motivate me to create more and more videos for you. Thank you very much. So let's begin with Zener diodes. As you can see here, so this is Zener diodes. So these diodes basically are Zener diodes. So this black mark means this is the cathode or the negative terminal, and here we have the positive terminal or anode. Okay, so cathode, anode, cathode, anode. Okay, cathode, anode. Okay, so let's check right now Zener diodes, of course using the multimeter. So let's check. So of course the black probe, it's begun with this one. So the black probe here in the cathode and the red probe in the anode, we get a reading. Good Zener diode, but let's swap the probes. No reading. Good. This one, for example, here we have the cathode, black probe, red probe. We get a reading, so if I swap the probes, I should not get anything. Nothing. Good Zener diode. Okay, so let's check this one also. So black probe in the cathode and the red probe in the anode, we get a reading. If I swap the probes, I should not get anything in the multimeter, as you can see. So this is the Zener diodes are good diodes. Okay, now let's check the normal diodes. So here, as you can see, we have a normal diode. This is a diode where we have this mark means this is the cathode, and here we have the anode. We have plus. So the anode is the positive terminal and the cathode is the negative terminal. So let's check this diode. Of course, always we're gonna use the diode option. The black probe in the negative terminal or cathode and the red probe in the positive terminal, we get a reading about 150. Good diode. If I swap the probes, I should not get anything in the multimeter. So let's check. As you can see, nothing in the multimeter. Okay, so also this is a good diode. I have here another diode next, as you can see, to the battery connector. Okay, always you will find diodes near to battery connector and of course near to the power jack. You know why? Because this is protection diode. So let's look at the cathode and the anode, as you can see here. So this is basically the cathode here, and over here we have the anode, we have plus here. So let's check this diode also, using always the same working principle. So the black probe here in the negative terminal or the cathode and the red probe into positive terminal, we get already good diode. If I swap the probes, I should not get anything in the multimeter. So let's check. Nothing in the multimeter, as you can see. Nothing in the multimeter. Also, this is a good diode. So let's move on right now to another component. So here, guys, as you can see, we're gonna check right now the fuse, the SMD fuse. This one, for example, this is a fuse. We have F7, as you can see over here. That means this is a fuse, okay? So of course we're gonna use, as always, the continuity option to check the fuse. So let's check it right now. A low resistance means this is a good fuse. This is a good fuse. So the same working principle, the fuse and the current sense resistor, as you can see over here, this is current sense resistor. If we check it, we should get a continuity in the multimeter. So let's check. A low resistance, the same as the fuse, means this is a good current sense resistor. You know why? Because the current sense resistor is just a shunt, okay? Like a wire. That's why when you test it using the multimeter, you should get a continuity or a buzzer. So here, for example, we have another fuse. As you can see, this is another fuse. We have F1 next to the VGA connector, okay? So let's check this fuse also. So we should get a continuity in the multimeter. So let's check. As you can see in the multimeter, means this is a good fuse, okay? So guys, that's it for this video. I don't want really to make it a very long video. So we're gonna continue in the next video the other parts, means ICs, resistors, etc. Okay, so thank you very much, and please don't forget to subscribe if not already subscribed. Share the video for other people like you, and please like the video, because your likes motivate me to create more and more videos for you. Thank you very much, and see you in the next video.